All righty, it's 12 o'clock and it's time for the Iowa Learning Farms webinar. Welcome to our first webinar of December 2025. I hope everybody had a great Thanksgiving break. If you weren't on, we had a great webinar last week. Kurt Miney talking about Paul Johnson. So that's on our archive page. So if if you just need something a little bit different and reflection, go take a look at that. And so today we are fortunate to have Michael Otten with Shive Hattery talking to us about designing ponds for private landowners. As always, if you have questions, please type those into the chat box and we'll get those to Michael at the end of the talk. But with that, the virtual floor is all yours.
Okay, how about now?
Yep, that looks good.
Okay,
or sounds good.
All right, well, we'll go ahead and get started. As Matt said, my name's Michael Otten. I'm a water resources civil engineer with Shive Hattery, and today we're going to go through a little bit about designing ponds for private landowners. So just a little bit about myself. I grew up here in central Iowa in West Des Moines, got my civil engineering degree at Iowa State, and kind of ended up going down the water resources path, mostly because of my passion for the outdoors. I'm big into hunting, fishing, hiking, camping, you name it, things outside I love to do. And so water resources really aligns well with my hobbies and passions and lets me work on projects that promote conservation and good wildlife habitat, things like that. At Shive Hattery, I'm a member of our water and environment market, and I work out of our West Des Moines office. Some different services that we offer include urban stormwater management, rural watershed management, lake restorations, pond design, wetland design, and more as well. So just kind of two main topics that we'll dive into today. In permitting, we'll review the involved entities, some general criteria and responsibilities that you'll have as a dam owner. And then also we'll touch on some of the design things like site needs and other considerations that either you as an engineer or a landowner would make during that phase. So we'll just go ahead and jump right into permitting. So one of the entities that you'll be in contact when you start your project will be the U.S. Army Corps of Engineers. They manage permitting for and determine all impacts that projects have to waters of the United States. Another term for waters of the U.S. is WOTUS. You may have heard that before. And they determine all the jurisdictional streams and wetlands. But the way that we initially kind of figure out where those are and in what quantity is through an official wetland determination by a certified professional. In our office, we have an environmental scientist on staff that completes that work. And so looking at your site and where those impacts might be, if it's identified that you have 1/10 of an acre or more of impacts to streams and wetlands that are jurisdictional, those impacts must be mitigated for. And in the state of Iowa, mitigation is handled through the purchase of mitigation credits from a mitigation bank. And it's in the landowner's best interest that we select a site that has little to no WOTUS impacts and identify if there are impacts, that we identify those up front because credit purchase can get expensive really quickly. We're talking into the tens of thousands of dollars. And so we don't want to get to the point where your pond is completely designed and you're ready to build it and then find out that, you have $50,000+ of mitigation that you have to purchase that maybe you weren't accounted for at the start. The other entity that you'll be in contact with is the Iowa Department of Natural Resources Dam Safety. They are the ones who will permit your embankment if it meets certain thresholds. Those thresholds are listed below in that table. So if your dam has a height of at least 25 feet and a storage of 15 acre feet or more at your top of dam elevation, or your dam has a storage of 50 acre feet or more at the top of dam elevation and a height of at least 6 feet, then you do need to go through the dam safety permitting process. So you can kind of see you could have a really tall embankment that doesn't hold necessarily a lot of water, or a smaller embankment that holds a lot of water. But if you hit either one of those criteria, then you are required to seek approval and receive a permit from the Iowa DNR. That image to the right there, in case people don't know what an acre foot is, just gives a graphical showing of what that means. It's just a measurement of volume. And so if you have an acre sized area, if you store 1 foot of water over that entire acre, then that's an acre foot, essentially. Once you determine that dam safety permitting is needed, the next thing is to assign your hazard potential to your structure. There's 3 different hazard potentials that the DNR recognizes, and those are low, significant, and high hazard dams. If your structure is a low hazard dam, the criteria for that is that if your embankment were to breach and fail, that failure would result in no probable loss of human life, have low economic losses, and low public damages. And so you can think of that, if your embankment were to breach, maybe it washes out, a drainage way, and it comes in contact with a low traveled road, and that road needs some minor repairs, such as resurfacing or things along those lines. Significant hazard dam is one, again, where failure would result in no probable loss of human life, but it may result in significant economic loss or public damages. Example of this would maybe be, again, no harm to humans, but maybe it's a public body of water where there's a lot of recreation done. And so if that pond or lake would drain, there'd be a lot of damage to the public. Or maybe there's a road downstream that's more traveled, and if your embankment would fail, it would completely wash that out. There'd be a lot more significant damage that would happen, then that would classify it as significant. And then lastly, a high hazard dam is one where failure would result in the probable loss of human life. So if there's a house directly downstream of your dam, and if it would break, it would send a wall of water towards that house and could destroy that house and whoever's inside. That is how it would get that high hazard classification. It is important to note that hazard potential ratings for a dam can change in the future due to downstream developments. And even if you're not responsible for those downstream developments, as the dam owner, you are responsible for any future upgrades due to a hazard potential change. So that's something to kind of keep in mind. If you're aware of things that might happen in the future directly downstream, that could push maybe what is now a low hazard dam to a significant hazard. It'd be a lot cheaper to maybe over-engineer your pond now with a bigger spillway and other design features to meet those criteria that a significant hazard would have, because down the road you would be on the hook for making any upgrades if that hazard potential would change. Once you determine your hazard potential, then it's time to submit your permit application once you've gotten into some of your design. As the dam owner, you would be the applicant for that permit. You might have it submitted on your behalf by an engineer, but you would be the applicant. And you'd be submitting a joint permit application to the DNR. They review both dam safety as well as any floodplain impacts that may be made. And I've listed right there a bunch of different design documents, plans and specs, operating plan, easements, design reports. Those are all things that they will be looking for as part of that application. And so it's something that, you need to hire a licensed professional to complete, because there need to be signed and sealed documents that are delivered. It's not something that, you could just sketch up quick and send along with an application. It is something that they do need licensed professionals to complete. And then finally, a water storage permit must be secured from the DNR to legally impound any amount of water in Iowa, if your dam does meet the thresholds for needing a dam safety permit during that application, that's all kind of included and you don't need to separately apply for it. But if your structure is small enough and you don't need a dam safety permit, then you still need to get this water storage permit, and it's something that you would have to do separately, basically. Okay, once your dam is designed and built, your responsibilities as a dam owner don't end there. There's also things for the life of that structure that you're going to need to maintain and do. And so just a few examples there of things that DNR looks for and things that as a dam owner you should be paying attention to. Keeping the dam well vegetated with a good stand of grasses is important to help reduce erosion and issues related to that. But while we want it vegetated, we don't want to have trees and brush on the dam. So removing those plants have a lot deeper root, be more damaging, that could damage your pipe. It also introduces new avenues for water to seep into your embankment, and it just has a higher risk of failure. And so we want to make sure that we remove those. Preventing and repairing any erosion, clearing your spillway of any obstructions. If you have corn stalks or tree branches that float into it, those spillways are designed on the basis that they're free flowing. And so we want to make sure that air can freely flow through them and it doesn't cause issues if a storm comes through. Any structural, and then maintaining any mechanical appurtenances. So if you have like a drawdown pipe and it has a valve or a gate or you have clogs or things like that, testing those features at least on an annual basis is always good. Emergency and for some reason you would need to operate those, you want to make sure that they're working and not find out, during the emergency that they don't work. And then also just completing owner inspections. If you're out at your pond, taking a look and making sure that all these maintenance items are kept up. It's a lot easier to do a lot of these small little maintenance items to prolong the life of your pond rather than not paying attention to them and then having a bigger repair down the road. Costs a lot more money and a lot more effort. And then in addition to some owner inspections, there's also DNR inspections they do in conjunction with the dam owner. And depending on your hazard classification dictates how frequently those are completed. If you have a low hazard dam, they say possibly periodic. And the reason they say possibly is it's pretty unlikely of a low hazard dam, it will get inspected. Due to the fact that there's a lot of low hazard dams across Iowa and there's just not the staff at DNR to do that. And since they have a pretty low risk, those are the ones that they tend to not inspect if needed. Significant hazard structures are inspected every 5 years and high hazard every 2 years. And at those inspections, they might identify the maintenance items that you need to perform. Okay, so that's kind of a high level overview of permit. Now we'll jump a little bit into the design side of things. So the first thing to do when selecting your pond is, where is it going to go? And one of those things, as I kind of discussed earlier, to take into account is any concerns with permitting or environmental impacts. If we can avoid environmental impacts, one, it makes permitting go a lot quicker, easier. But then two, also, you don't have to purchase mitigation, things like that, and just keep your project a lot lower in cost. And so if we identify features on where you want your pond, but maybe we can shift that embankment, upstream or put it in a different draw to avoid those features, that's always best to do. And then also to review your watershed that's draining to your pond. So there's something called ratio that we look at. Basically, that looks at for every surface area acre of pond that you have, how many acres of watershed do you have draining. But ideally, it kind of falls in that 10 to 50 acres of watershed for every surface acre of pond. Thing lower than 10 will really struggle to maintain a full pool throughout the whole year, especially it gets dry. And then if you get too high, like up in hundreds of acres to one, that's when you start having issues with, sedimentation, and you might have to more frequently like dredge out your pond. So that's kind of a sweet spot that we shoot for. And then also with your watershed, it's important to notify your engineer if you as the landowner know anything about any natural springs or tile fed areas that might not look like they drain to your pond, but you know that they do. That's something to account for in our design calculations when designing the embankment. Once you have your site selected, then the next thing to do is to design your spillways for your dam. There's two different types of storms that we look at, and one of those is the spillway design flood, and basically designs like the pipe that's going through your embankment. So for a low hazard dam, that's a 10-year storm, significant is a 50-year storm, and a high hazard is a 100-year storm. Sure you all have heard that term, like 100-year storms before. In case you don't exactly know what that means, it doesn't indicate that storm's only going to happen, once every 100 years. Especially recently, we are getting higher storms occurring. And basically what that means is you take 1 over 100, and that delivers a 1% chance of that storm occurring each year. These storm events for the spillway design flood are used to design your principal spillway. And those storms need to be passed through that principal spillway without utilizing your auxiliary or emergency spillway. And then the freeboard design for the low hazard dams is the 100-year, the 1,000-year, and your high hazard dams are the probable maximum flood. Those freeboard design floods, they help design your auxiliary spillway, and those storm events must be passed safely through that auxiliary spillway without overtopping your dam embankment. So this storm also kind of sets that top of dam elevation as well. And then when you are looking at where that elevation lies, it's important to trace back up your drainage exactly how far that. You really want to try to keep your top of dam on your own property. If you don't, and it impedes onto your upstream neighbors, then you will have to secure an easement from them. Even though you're not permanently storing water, you have the potential to temporarily store water on their property, and that is an impact to them. And so you would need to get an easement if that is the case. Okay, a little bit about outlet systems. There's various outlet systems that you could install. One just being a culvert through the embankment. So like a CMP, a metal pipe, concrete pipe, plastic pipe, just running straight through the embankment. That doesn't give you a lot of options, like what a drop inlet and pipe would, which are two options to those are shown in the images to the right. A drop inlet you can think of as like a vertical box or pipe that then has a pipe at the bottom of that structure that routes the water to the downstream end. Those structures also have the ability to have drawdown pipes installed on the upstream end that go into the pond. And then those drawdown pipes could be controlled by a gate or a valve, or utilizing stop log systems to give you the flexibility as a landowner to be able to draw down your pool or slightly lower your pool, things like that. And so if you want the ability to be able to control your water level, or in the future, if you need to draw your pond down completely to do maintenance work, those are good things to consider when installing your outlet system. They're always easiest to install up front, and helps to give you that ability later down the road. And then also making sure that your outlet has a trash rack on it. Trash racks help keep debris from clogging your pipe and keep those things free flowing. You will need to maintain stuff around those trash racks. And so if you have a big storm that washes a bunch of debris downstream, it might stack up outside of that trash rack so it doesn't get in the pipe. And so as a landowner, you'll have to go back and make sure that you're regularly clearing those after large storm events. Okay, the auxiliary spillway, which is designed using the freeboard design flood. These commonly are just open channels that are set a few feet below your top of dam elevation that during those big storms will route that water through that open channel and downstream in a safe manner. DNR specifies that those auxiliary spillways, if they are an open channel, should have a minimum depth of 2 feet and a minimum bottom width of 10 feet. And then also another good design feature to include is outlet armoring. This can be in the form of a plunge pool, riprap. You could even grout in that riprap if you have really high velocities, but making sure that we are dissipating that energy that water is carrying downstream is important. If we don't armor our outlets, then some things that could happen is erosion could cut under your pipe and cause that pipe to collapse, or it could just eat away at the toe of your embankment and would give a higher risk for failure. And so making sure that we stabilize that downstream channel is always important. Internal drainage. Unfortunately, all dams do leak. Whether we can see it or not, it's just kind of a fact. One of the most common ways that dams fail is due to water seepage through that embankment and not managing that seepage properly. One of those failure types is known as a piping failure. And so a piping failure is basically water gets right along the edge of that pipe and travels all the way to the downstream end. And over time, it opens up a void in that embankment and eventually it breaches. And so that is usually a result of poor compaction around that pipe or utilizing poor soils. And so as an engineer or a landowner during construction, that's a really critical time to kind of observe what's going on and make sure that the contractor who is installing that is doing a really good job of not only compacting over the top of that pipe, but around and underneath it to make sure that things are sealed up really good. And then there's also some different internal drainage solutions that we can employ to make sure that seepage is dealt with properly. One of them is anti-seep collars, which is seen up in that top image. Basically, that's just a collar that goes around the pipe, and when water hits it, that water is forced out and around. It doesn't stop the seepage from happening, but what it does is it makes for a longer and harder travel path for that water to get through. And then the better solution really is the sand drainage diaphragm. These are usually required on larger structures, but you can use it on any structure. But what that is, you can see it in the bottom image. It's basically a cross section of sand that water will hit along that pipe and drop into that sand and then find the perforated pipe and then flow downstream. And so what that does is it captures that water and gets it out. There's also some other geotechnical considerations that you should make. I'm not a geotechnical engineer, and so we always recommend, especially if your pond is maybe a little bit more sophisticated or on a site with a lot of variables, to have soil exploration completed. One thing that we always usually do with our designs is install a core trench. So before you even start putting dirt to build your embankment, you would over excavate that virgin material along your center line of your dam and replace it with a compacted layer of cohesive clay. And what that does is it helps to prevent any seepage from getting under the embankment. If you have a really tall structure, installing a stability bench on the downstream toe could be considered. Adding more weight down there helps prevent from any kind of slippage on that backside, and also just other soil considerations. If you're building an embankment where you have really sandy soils, sand can cause issues with ponds maintaining a consistent pool level because water finds that sand and it travels through that seam and leaves your pond. And so you might want to install a clay liner or bentonite to help seal that up. Or if you have really mucky, soft, wet soils, we would really recommend doing over excavation and replacement with better material, because over time, all the weight from your embankment will squeeze that water out and could lead to differential settlement and other issues. Shoreline stabilization is also a thing to consider during design. the last thing you want to do is build your pond and then have all your shorelines collapse in and you lose water depth because your shorelines are all the soil from your shorelines are at the bottom of your pond. One thing that we recommend always installing is a wave bench, especially on the face of your dam embankment. So basically what that is right where water level hits your embankment, we would grade in a flat bench, and that just helps to protect from erosion from wave action crashing there. As well as shoreline armoring on any areas that are really steep. This could be in the form of riprap or tied concrete block, just protecting those steep slopes. And then there's also other natural vegetation and erosion benches that could be installed, vegetation that can grow up to help lock in those soils. And then also if you're a landowner who has cattle, there are some considerations to take into account. As an engineer, obviously I'm not a cattle farmer, but it would always be our recommendation to fence cattle out of the ponds and off of the embankments. They can cause significant water quality issues and erosion issues. Even if we could keep them out of, a majority of the pool and off the embankment, that would be great. But there's also other ways that we could get cattle water by installing a pipe with a valve on the downstream end while keeping them away from those embankments, because they're a big heavy animal and they can cause a lot of issues along your shorelines and embankments. And then lastly, another good thing to consider is fish habitat. Fish habitat is really important to create a diverse underwater ecosystem. It helps create locations for young fish to seek refuge from predators. And if, fishing and recreation is a big reason as to why you're building a pond, installing them while that pond is being built is always a good idea. You can place features exactly where you want. You can see exactly how it's going to look like once it's underwater. It's just easier. If you wait for your pond to fill up, then you maybe have to throw things in or drop them off the side of a canoe, stuff like that. It's just not quite as easy. So if fishing something you really want to do there, fish habitat is always a good thing to install when construction's happening. A couple features listed there that you could consider are spawning benches, along shorelines and shallow areas, just putting in like pea gravel or small rock where fish can spawn. Rock piles with large riprap that provide voids for fish to hide in. Wood and rock habitat, pallet structures, PVC structures, and like sunken culverts are really good for catfish. Yeah, that kind of brings me to the end of my presentation. Hope that you guys learned a little bit about the permitting and design side of things there.
All right. Thank you very much, Michael. That was excellent. We've definitely got some questions, but let's maybe go to some of the logistical slides here, because I know somebody asked about this one. But if you watch this webinar live and are wanting to earn a CCA CEU, please email Alena Whitaker, ALENAW at iastate.edu by 5 o'clock today. Include your name, the name you entered to watch the webinar, and your CCA number. Again, ALENAW at iastate.edu. And go to the next one. If you watch this webinar live and are willing to fill out a voluntary demographic survey, we'd greatly appreciate it. Only one survey response is needed for all 2025 webinars. So you can go scan that QR code or go to the website iowalearningfarms.org/survey. Okay, next slide. We got Matt Stevenson talking to us next week about prairie strips support migrating monarchs and breeding birds. So something a little different, but should be interesting on thinking about prairie strips. And let's go think the next. And tomorrow, we do have a virtual field day exploring the impacts of residue management on crop yield and fertilizer inputs. All right, and next slide should be that we have this webinar will be archived, and all previous webinars will also be archived are archived, excuse me, at the iowalearningfarms.org/webinar site or the YouTube channel that's related to the Learning Farms webinars. Okay, let's get to some of these questions, Michael. We have quite a
Yeah.
few. Okay. So that somebody was asking about the Army Corps of Engineers being totally in charge. Should there maybe not be a water resources agency to weigh in as well as the Army Corps of Engineers?
So I guess typically for permitting, the Army Corps is the one who looks at, jurisdictional wetlands and streams.
Okay.
And so that's usually the only entity that we are in contact with on that. They might have some interagency communications with other parties as well, but related to that portion, that's who we're in contact with.
Okay. What is your company using for dam breach modeling to determine hazard class?
Yeah. So sometimes hazard classifications can be determined without having to do a dam breach analysis. You can kind of just look at what's downstream and if it were to breach, what it would impact. Now, if there are features downstream that you see and you're like, well, will water hit that and what damage could it cause, then the software that we typically use is HECRAS.
Okay.
To do our modeling.
Okay. If a beaver decides to build a dam and pond on one's property, how likely is it to be potentially dangerous?
That is a good question. I don't know if I'm an expert to talk about beaver dams necessarily. But I mean, obviously those dams aren't built structurally sound with compacted material. And so, large storm events could more easily wipe those out than an embankment. If a beaver dam's on there and it fails, seems like it'd be maybe a little unrealistic for somebody to come back on you and say that was a regulated structure because you didn't build it. But definitely something to keep in mind and manage.
Okay. You talked a little bit about concern with seepage from tree roots. Have people been concerned about deep-rooted grasses causing seepage similar to that feared from tree roots?
That is a great question. I don't know if I necessarily have the answer on that. A lot of times, I guess on embankments, we see grasses that are grown there, more like smooth brome, things that can establish pretty quickly and maybe don't have quite as extensive of root systems. I'm guessing maybe you're referring to some more of the native grasses with really deep roots. Those, we don't typically put those type of grasses on embankments. And so I think it would be better to, on your embankment, maybe lean more towards a different grass species than that. And off the embankment, you could use that native species somewhere else.
So this one kind of gets at the trees a little differently, but trees can't be placed on the dam, but can you intentionally plant trees around the impoundment? And if so, any recommendations for trees? That might be outside of your wheelhouse too.
Yeah, it's definitely good to keep trees off the embankment for the reasons that we talked about. And as long as they're not on the embankment, like up around the pool, if you just want some shade while you're fishing or for animals or things like that, that's totally fine. That's not causing any structural issues with your embankment. And then if you're going to plant them close to the pond, I would just recommend trees that like wet feet, swamp oak, things like that, sycamore,
So kind of a couple permitting things. I guess, have you seen more of a challenge with permitting in recent years? And are you seeing more issues with stream mitigation with newer dams?
Yes, we definitely are in recent years than historically in the past, and specifically related to streams. In the last probably 5-10 years, the Corps has definitely shifted a lot of their focus to protecting streams. And so, like I said, it's really important early on to identify if you do have a jurisdictional stream where you're planning to put your pond, because costs can get out of control pretty quickly.
What are some of the most common maintenance concerns you hear from landowners?
Yeah, I'd say probably mostly management of vegetation. I know on like some of our clients, some of their basins that we've constructed, sometimes they get voluntary growth of willows happening, and willows can kind of spread like a weed and sometimes are hard to manage. That's usually the biggest thing that you kind of have to do on a regular basis, I would say.
I guess in any of the pond projects you've been involved with, have you been involved with stocking of fish? Or has that been on the landowner?
Yeah, usually the landowner will handle that separately. We don't specifically haven't specifically worked with that, but if it's something that somebody wanted us to look into, we work all the time with the DNR on lake projects and stuff, and can always pick their brain, since they're probably more qualified to give a better plan on stocking of fish.
Okay. Have you looked at assessing how long the pond structure might last before it fills with sediment or the primary spillway needs replacing?
Yeah. There's some estimates and things that we can do. We can look at what your watershed's made up of. If you have a bunch of CRP in your watershed, your sediment delivery rate to your pond is going to be a lot less than if your entire watershed is row crop. And so we can take a look at the size of your pond and how much water is stored in there, and then make estimates on the amount of yearly delivery of sediment that you would get, and make a pretty good estimate on a life for your project for that pond. The other thing you can do also, if you want to prolong its life, is install some sort of forebay upstream. And so you can maybe more easily maintain like a small forebay and dig that out, and less frequently dig out like your larger body of water. And then related to spillways, just kind of depending on what type of spillway you install. A corrugated metal pipe will have a shorter life than reinforced concrete. It's still going to last decades if installed correctly. But metal pipe is a lot cheaper than concrete. So you just kind of have to weigh your options of time versus cost.
Do you typically have a geotech exploration completed for all your pond projects?
Yeah, I wouldn't say all of them, but I would say a majority of them, especially if they get to be kind of like taller embankments. We usually do.
Okay. And have you worked with government agencies that can help provide cost share on these projects?
Yes, we have. Usually the landowner comes to us after kind of already contacting maybe like NRCS or IDOLs, and getting a project set up. And so they kind of already have had that out, but it's definitely something that we're familiar with and can assist with if it's something like a landowner doesn't want to deal with.
Okay. Somebody asked if you can cover the mitigation credits again.
Yeah. Let's go back to that slide quick. Yeah, so if it's determined during a wetland delineation that by constructing your pond, you're gonna impact more than 1/10 of an acre of streams or wetlands, then you need to purchase mitigation credits. And what mitigation credits are is basically there's different mitigation banks that people have set up throughout Iowa. So what they do is they take, upland fields and produce wetlands, or really poor streams that are in real poor shape, and they rehabilitate those. And what the Army Corps does is they allow those positive impacts to be offset by your impacts. And basically those credits are sold on the open market. So depending how many credits the Corps determines you need to offset your impacts, you'll have to go through a bank and purchase those credits to show the U.S. Army Corps that you've mitigated for those.
Okay.
Does that make sense?
Yep. Yeah, it does. Any recommendations for auxiliary spillway slopes and surfacing for passing farm equipment across the dam?
Yeah. As far as, I guess, passing farm equipment across the dam, as long as your embankment's wide enough to hold it, then a lot of times you're fine just driving across. If it just has a good stand of vegetation, you don't necessarily need to armor that. You always can add a little bit of rock if you're having issues with rutting and things like that. And then your auxiliary spillway, I would say as flat as you can get it is always better. Just because if you do have water using that auxiliary spillway, it's going to be in a high recurrence storm, and so you might have a good amount of water going through there. So there isn't necessarily like a target that we always reach for. It's kind of dependent on the site and what you can make work, but as flat as you can get it.
Yep.
Sure.
Here, a little more engineering question. So they've heard that the sand gradation can be very important, especially for the sand diaphragm, but depending on the nature of the fill used for the embankment, do you ever specify a D15 for sand gradation?
I guess for the the sand drainage diaphragm, we typically would say, it has to be like a gradated sand that is clean, and so not something that they like just pull out of the river and has like fines built into it. So I don't have an idea off the top of my head, but we do typically have some sort of specification for that material that is put in there.
Okay. Okay, so they did say, back to your required design storm, they were asking if you were using from a specific standard, or maybe if there's a source maybe for that storm information.
Yep. Yeah, so the requirements for these different design criteria is from the Iowa Code. I think it's chapter 73 of like the environmental code. These are requirements that DNR follows and will require for you to adhere by. And then as far as like the storm recurrence intervals, the rainfall data is all used from NOAA Atlas 14, which is just an online source that you can go to and basically click where your site is, and it'll populate all those rain events for you.
Okay. I guess, this is maybe more on the management of the pond, but have you worked with any landowners on kind of keeping the pond clean, maintaining for fish and that kind of thing?
Not usually. I would say we've mostly been involved with the help of designing it. We do work on projects where landowners dredge out the ponds, and we'll help design those, things like that.
Okay. Have you done any excavated ponds where the inlet and outlets are tile lines? So the goal being to function as an accumulator for excess rain when there's an undersized tile main?
I don't think specific. Trying to think of the application of that. So maybe not I don't think I specifically have, but definitely
Okay.
something that we could handle.
Okay. Are you running into issues with contractors not knowing how to properly construct sand diaphragms? This brings me back to my days as when I functioned as a field engineer, as a geotechnical engineer, and and struggling. But that was 30 years ago. So
Yeah, I think it's a little more common now, but
okay,
yeah, definitely. Anti-seep collars are a lot more familiar with some of the
okay,
smaller contractors than sand drainage
and
diaphragms,
sand
but
diaphragms. Okay,
yeah, it's definitely something you just kind of have to, keep an eye on during construction and make sure that they know exactly what's supposed to be going on.
okay. Well, Michael, I think that gets at most of the questions maybe that are specifically related to kind of some of the engineering of these. So, really appreciate your talk today. I think it gives us all something to think about and helpful in things we need to think about if we're considering a pond. And so, want to say this will be up the recording, so people can go back and watch it. Also, please tune in next week for Matt Stevenson on prairie strips for migrating birds or grassland birds and monarchs. And with that, I hope everybody has a great rest of the week. Please tune in next week and consider tuning in tomorrow for Dr. Castellano. So.
Thanks, Matt, and